Now we come to another very important concept in classification, and that concept is the concept of the cutoff probability. It is sometimes also referred to as the discrimination threshold. I'll be using the term cutoff probability, but if you come across the term discrimination threshold, you should understand that it means the same thing. Once again, this is something that is common to all classification techniques, the notion of the cutoff probability. So once again, instead of discussing this in the context of specific classification techniques, I'm talking about it in general, which is applicable to all classification techniques. Okay, so once again, let's get into the general steps that are involved in classification. Right, we already know that here is our new data for which the target attribute value is not available. We then apply the model, and till now we've been talking as if applying the model is going to tell us which class each case is going to belong to, right? Till now when we applied the model, we said buyer, non-buyer, fraudulent, genuine, etc., etc. But in reality, the way in which classification models work is you apply the model and they generate the probability first, right? So for example, in this case, we might talk about, given all of these attributes, what is the probability that somebody is a buyer? Okay, so the step is not directly going from data to an actual classification, buyer, non-buyer, etc. Instead, the intermediate step is that it first calculates a probability. Okay, so in this case, what it's saying is that whatever the data is on the first row, based on that, the model says there is only a 0.3 probability of that person being a buyer. Okay, whereas for this particular case, it is saying there is a 0.8 probability of 0.8 that this person is going to be a buyer, or even for this person, there is a probability of 0.9 that they're going to be a buyer. Whereas for the last case, the probability is only 0.33 of them being a buyer, right? So obviously, if the probability is low, it means that case is very unlikely to be a buyer. If the probability is high, it means the case is very highly likely to be a buyer. Okay, so all classification models first produce a probability. Okay, the probability is then converted into an actual prediction. Okay, so this is what you've got here. Classification methods usually compute a probability. The probability is then converted into a prediction by using a certain probability as a cutoff. Okay, so in this particular case, we are using a cutoff of 0.5. What we are really saying, therefore, is if a case has a probability of 0.5 or more of being a buyer, then we are going to classify them as a buyer. Less than 0.5 becomes a non-buyer, right? So we are taking the probability and converting it into an actual class. So look at the first case. The probability is 0.3. Well, that's less than 0.5, thus that person becomes a non-buyer. Second case, 0.45. Once again, less than 0.5, non-buyer. Okay, so take a look at this case, 0.67, greater than 0.5, buyer. 0.80, buyer. 0.45, non-buyer. 0.75, buyer, right? So you can clearly see here that any probability that is less than 0.5 becomes a non-buyer, and any probability that is greater than or equal to 0.5 becomes a buyer. Okay, that is because the probability that we have here is the probability of a person being a buyer, right? Of course, conversely, you can also calculate the probability of somebody being a non-buyer, which is just 1 minus this value. Okay, so this is the general process that happens for any classification technique. It first calculates the probability and then converts the probability into an actual class based on a cutoff value. Okay, and the usual cutoff value, the default cutoff value that is employed is 0.5. But there's no reason why we should just take the default. There are very good reasons for us to look at alternatives, and we'll be looking at that aspect shortly. So let's look at some examples of using different cutoffs. Now we already saw the result when we use a 0.5 cutoff. It should be comma, not comma, it should be a dot. This is a 0.5 cutoff. Then it gives this classification. Now what happens if we use a lower cutoff? Let's say we use a 0.4 cutoff, right? Just think logically, what's going to happen? if our cutoff for accepting somebody as a buyer is a lower probability, then obviously more of the cases are going to be classified as buyers. So for example, a case like 0.45, probability of 0.45 was classified earlier as a non-buyer, but now, because then the cutoff was 0.5, now that the cutoff has been lowered to 0.4, this particular case is now classified as a buyer, right? So as you lower the threshold probability, cutoff probability for somebody being a buyer, obviously you're going to get more buyers and less non-buyers, right? So this is common sense. And of course, if we increase the cutoff, then we are being more stringent in accepting somebody as a buyer, so you'll have less buyers than was otherwise possible. Okay, so if you lower the cutoff, you expect more of the cases for which you're applying the cutoff, and if you increase it, you'll expect less. Okay, so here is a case where we are using a 0.7 cutoff, which is higher than 0.5. So obviously you expect fewer cases to be classified as buyer, right? So for example, let's take a case which was between 0.5 and 0.7. Here is a 0.67, which was earlier classified as a buyer. Now the 0.67 has become a non-buyer. Okay, that's because our threshold or cutoff is now 0.7, not 0.5. Okay, so with different cutoff probabilities, the final classifications will be different. Okay, and like I said, the default is usually 0.5, but there's no reason we need to stick with the default. We can explore the possibilities, right? So for example, one reason why we would look at different possibilities is if you lower the cutoff, for example, to classify somebody as a buyer, then more of the cases will be classified as buyers. Okay, in other words, what's happening is likely more non-buyers will be now accepted as buyers. Okay, and conversely, many people who were actually buyers, right, but were treated as non-buyers, if you lower the cutoff, then you will catch some of those buyers, right? So for example, somebody with a probability of 0.4, but the person was actually a buyer, the 0.5 cutoff would have eliminated them. Whereas if you used a 0.4 cutoff, you'll catch those buyers. But of course, that is going to happen at the cost of you accepting more non-buyers as buyers, right? So the logic of why would you lower the cutoff is because you may think it's worth for me to get several non-buyers, but if I'm also going to get a few buyers, overall, I make out better because the profit I'm going to make on those extra buyers is going to offset the minor losses that I make by devoting time and attention to the non-buyers. Okay, so it's a trade-off. That's what is going on here.